So our next presenter is Garima Pal. She's from IIT Kanpur, and our topic of presentation is like generation of gestures in now robot mimicking child's primary emotions. Yeah, so Garima, you can start now.
Hello, good evening everyone. Today I am presenting my research on topic generation of gestures in now robot mimicking child's primary emotions. The principal investigator of this project is Professor Bishak Bhattacharya. So, emotions. Emotions are part of our daily lives. Emotion and its physical expression are an integral part of social interaction. We use emotions to inform others about how we are feeling. But autistic kids often find it difficult to recognize and manage emotions. They either lack confidence or feel shy to express themselves. Moreover, they fail to understand what their surrounding people are trying to express. So, by learning to recognize and manage emotions, it can help autistic children to understand and respond to other people. It will also increase their confidence and social adaptability. These are the few images in which emotions are expressed through body language. Next, uh, we all know that robots are promising tool for promoting engagement of autistic children in interventions and thereby increasing the amount of learning opportunities for autistic kids. If robots express their emotions during child robot interaction, it will increase the ability to understand and respond to emotional cues in autistic kids. In our research, we have used Now Robot to embed gestures that are generally used by children to express their seven primary emotions. The gestures are generated that are generally used by normal children. Uh, while emotions can be expressed through different modalities, facial expression is the most common way. Other way is our body. Our body also conveys emotional information. Like we generally tend to lean forward to show interest while talking with someone. So, expressing emotions through body movements by robots can be used as a child robot interaction paradigm to help autistic kids to learn about emotions. This is the picture of a child playing with robot during one of our experiment conducted by SMSS lab IIT Kanpur. So, experimental procedure. The step one was data collection. In our research, we first collected body actions of children corresponding to seven basic primary emotions, which are happiness, sadness, angry, surprise, fear, disgust, and neutral. We went to a nearby school and collected data from 50 students of age group like 6 to 10 years old. We gave them scenarios corresponding to each emotions so that they can act or show that emotion using their body actions. Like for surprise, we asked them like how will they react when they woke up in the morning and see a lots of gifts from their parents. Similarly, for disgust, we gave them scenario like how will they react or feel when a crow beats on their hand. So, while giving these scenarios, the children reacted and shows their emotion through body actions. Here are some clippings of the body actions shown by those children. This one is fear. Next one is surprise. So in this way, we collected like 350 videos, 50 videos corresponding to each emotion. All the videos are of like 2 to 4 seconds. The next step was video data validation. We did validation in two stages. In first stage, we showed all 350 videos to 30 people. After getting the votes, the maximum voted videos, we kept those videos. We were left with like 74 videos, like 7 to 8 videos of each emotion. In second stage of validation, we again showed the remaining 74 videos to different group of children. This time by masking their face by now robot's face. This is to avoid any contamination like judging emotion from their facial expression. After second validation, we got two videos corresponding to each emotions. Here are some other videos that we have recorded. The disgust shown by a child, happiness, sadness, and angry. The next step is to extract pose data from video. After collecting the videos, now we have to collect the data of body joints. The body landmarks are shown in the figure are extracted from the videos. The tracker locates the region of interest, that is the person in the video, and it estimates the 3D coordinates of 33 body joints. The body points that are extracted by this pipeline are shown in this figure, pose landmarks. Now, using these extracted coordinates, we have built a model whose outcomes can be fed to Now robot to generate motions. This algorithm maps these 3D extracted coordinates into Now's kinematics. Here are the few snapshots from the pose extracted from recorded videos. This is the video showing pose tracking. It can capture the motion of body and gives the 3D coordinates of the landmarks. Now, designing hand motion. Designing hand motion using extracted coordinates. To operate Now, we used choreograph suite software of Now robot. As you can see here, to generate hand motion, we will be needing these parameters, these angles of Now robot. They are shoulder roll, shoulder pitch, elbow yaw, wrist yaw, and hand. Hand in the sense like whether it is open or closed. So we build an algorithm that calculates these parameters. We use those extracted 3D coordinates and use a logic and mathematics to calculate these angles. Then these angles are fed to Now robot using choreograph software to generate actions. Here are some of the pose and angles extracted corresponding to different poses. Here you can see the different angles, shoulder pitch. LSP represents left shoulder pitch. I have represented only left hand angles in this slide. LSR represents left shoulder roll. LER represents left elbow roll. All these angles are in degrees. So this body joints extracting algorithm extracts almost accurate angles, as you can see here. Next, we have tried an action that is replicated by Now robot. You can first see in simulation, and then we have tried that with our robot in our lab. Now, here are few limitations. Because of design of Now robot, there are some poses that cannot be replicated. As you can see in this diagram, left arm of Now, you can see the elbow roll range is of 90 degrees only. But in human body, this angle can be as minimum as like 20 to 30 degrees. So this action cannot be replicated by Now robot. Secondly, when we raise our hand in sideways, we can raise our hand like about or more than 90 degrees. But due to design constraints in Now, this action also cannot be replicated to this much extent. So all actions cannot be generated by Now robot because degree of freedom of robot is limited, and it cannot replicate the complex actions that are performed by humans easily. So future scope of this is this model can be further modified to make real-time imitation play game during child-robot interaction. The kinesthetic model can be used with other robots as well to generate motions. Thank you. Any questions?
Yeah, thank you, Garima, for that presentation. Uh, so that was a nice one. I would request any question from the audience regarding the work.
I have a question. Which software did you use to get the body joint values?
I have not used any software. It is an open library in Python that I have used.
Okay. May I know the name of the library?
MediaPipe.
Okay. Thank you. Thank you very much.
So Garima, I have a question.
Yes, sir.
So, I mean, what is the purpose of building this basic emotions into actions? Like, can we like make some like very complex dynamic actions by the robot? Like,
the basic idea behind this was to train autistic kids by showing the emotions that are generally used by kids in India. So as we have in Now Robot, there are no inbuilt these emotions. These emotions are not inbuilt in Now Robot. So to create those actions, we have tried to capture the emotions that are generally expressed by children and try to replicate those gestures into the Now Robot.
so like after generating the gestures, you want to use it with autistic kids. Is it the idea?
Yes, we can use these emotions to set up a gameplay with autistic kids and robot.
Thank you. Is there any questions from audience?
Garima, I have one question. In human, we shows our expression through means facial muscles and all these things. In Now, those things are not there. Then
Yes.
how you replicate those things?
So we are replicating only body movements, not facial expressions.
Okay. Okay, only through body means
Body
larger
actions.
body movement.
Yes.
Okay. Okay, got it. Thank you.
So is there any more questions? Then like, thank you, Garima, for that presentation.
Thank you, sir.